All right, here it is. The big kahuna, trigonometry. Okay, we're going to talk about trigonometric ratios. Okay, and we are going to. Now, where's the eraser? Oh, found it. Okay. Trigonometry comes from two Greek terms, trigon meaning triangle and metron meaning measure. So we're measuring triangles, right triangles at that. Okay, and it comes from angle similarity, which we'll talk about later. But we don't need to know all of that to know how to use the trigonometry. Now, just a cool part to know is so the reason we can do it is because we have these two triangles. And now, are they congruent? No. But what do you notice about them? Hopefully, notice they both have a right angle and a 35-degree angle. And that means by the third angle theorem, which we did talk about, that angle G and K are congruent. So these triangles are not congruent, but they do follow that angle, which means even though they're not congruent, they have the same shape. And that actually leads us to an even more powerful thing than if they were just congruent. Because now we can get a small version of the triangle and a big version of the triangle. Knowing that they're the same shape, we can measure large distances. All right, so stay with me, and it will only make more and more sense. So what you need to know is your trigonometric ratios. We have sine, cosine, and tangent. If you have TI, hold on, I'm going to go get my graphing calculator. If you have the graphing calculator, you may have noticed that it says sin, cos, and tan. Now that's not sin, that's sine, cosine, and tangent. And what those are ratios of sides in a right triangle. So sine is the ratio of the opposite over the hypotenuse. Cosine is the adjacent over the hypotenuse. Tangent is the opposite over the adjacent. So I don't know why I don't see it here, but we remember that with the phrase SOHCAHTOA, which I said at the end of last class, or I like to write it like this. Sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. And TOA, tangent, is opposite over adjacent. All right, SOHCAHTOA. How can you forget that? It's a fun word to say. So what do? We got to find, let's do our first guided practice. Find the sine of J. So what does that look like? Sine of J. Okay, so here's angle J. So what I'm going to do is, the first thing I'm going to do is label sides opposite, adjacent, and hypotenuse. I always label my hypotenuse first because it's across from the right angle. So that's my hypotenuse. And then I look at the angle in question. That's angle J, right? So angle J, one of the sides is the hypotenuse. The other side is the adjacent. It's always that way. One side of the angle is the hypotenuse and the other is the adjacent. Because some people have trouble knowing what is the opposite side. Not me. I always look across the figure and like, the side across is the opposite. But if that's difficult for you, just know that everybody knows what the hypotenuse is. That's the one across from the right angle. That is usually the easiest one to identify. So we'll start with that. Then the adjacent side is the other one that borders the angle. That only leaves you the opposite. we think about it that way, maybe all be able to label the sides. Because once you label the sides, it's going to be pretty easy from there, as long as you remember. SOHCAHTOA. SOHCAHTOA. All right, so the sign is the so part. So that means we want to put the opposite over the hypotenuse. So the sign of J is the fraction 5/13. What is the cosine of J? That's the ka, the adjacent over the hypotenuse, the fraction 12/13. And so we got that, we got that. What's the tangent of J? That is the opposite over the adjacent, which would be 5/12, 5/12. And then how about the sine of K? Well, now we better do this one in another color. Okay. So now I'm just gonna have to go ahead and redo everything now, because now we're talking about angle K. So with respect to K, well, the hypotenuse is still the hypotenuse, but now the adjacent side has changed. Now the adjacent side is 5 and the opposite side is 12, because now it's all about angle K. All right, so what's sync? What's the sign of K? All right, so the sign of K is the opposite, 12/13. Okay, what's the cosine of K? Cos. Cosine of K, adjacent over hypotenuse, is 5/13, 5/13. And the tangent of K, tang, what's tang? Is 12/5. And hopefully you noticed something that is, hey, Mr. Brown. All right, we're all good. So now hopefully you notice that there are some similarities. So the sign of J, 5/13, is the same as the cosine of K. That same thing happens with the cosine of J. Look at that, same as the sine of K. And then there's only one left over. They are opposites, or they're reciprocals. All right. So that's the big one, the trig ratio. Now, use a special right triangle to express the cosine of 45 as a decimal to the nearest 100. Are we going to do that? Cosine of 45 degrees as a fraction and a decimal. Oh, yeah. Okay, so we know that we have our 45, 45, 90, right? And we know that in a 45, 45, 90, the formula is x root 2. And so what's the cosine of 45? Adjacent, hypotenuse, opposite. Okay, so the cosine is adjacent over hypotenuse, right? Can't say that enough. So that's going to be x over x root 2. But what do we see on the top and the bottom? We see an x. So it reduces to 1 over root 2. We know we can't have square roots in the denominator. So we're going to have to multiply by root 2 over root 2. And we get root 2 over 2. Square root of 2 over 2. All right. So that is a well-known fact, actually, that the cosine of 45 degrees is equal to the square root of 2 over 2. I even have the decimal memorized as 0.707. Okay, so we'll talk more about that. But just to know that all your special right triangles have really important fractions for later on. But for this section, this is the kind of thing that is more important to me. Right, that we would be able to solve special electronic. This is the last one too. Ooh, inverse. Okay. Yeah, don't you worry. We're only doing this one section because you can see it's quite long. Okay, so we are going to find x to the nearest time. Okay, so how are we going to do that? Okay, I got an idea. We're going to circle the angle, and then we're going to label the sides. So this is the hypotenuse, this is the adjacent, and that's the opposite. You with me? Now the next question is, label sides, determine ratio. So what should we use? So, ka, or toa? Well, we have the adjacent side. We want to know the opposite side. And the hypotenuse is not part of that question. It's not the side we're given. It's not the side we want to know. So O and A. Which ratio connects O and A? O and A. It's TOA. All right, so we want TOA. So we're going to use the tangent 25 equals O over A, X over 18. And usually what I have the classes do is put the ratio over 1, and then we'll just cross multiply. X times 1 is X, and then 18 times tan 25. Now what we do is we go to one of my favorite websites, Desmos. Let's learn together. Let's indeed. So what are we doing? We're doing 18 tan 25. Now, forewarning, you will get every question wrong in IXL if you do not. Make sure you press this wrench and go to degree mode. So we're working in degrees. We want 18 tan 25. And the answer is 8.39. Approximately, right? So that's how we do that. But guess what? Once you know how to do it, we're going to do the same thing for all of them. So the third step was to cross multiply. Go to Desmos and star, star, star. Make sure you are in degree mode. All right, so let's try 3B. We have angle 70, hypotenuse adjacent. Don't care about the, that's confusing. All right, so which ratio is the hypotenuse and the adjacent? That is ka. So I'm going to write cosine of 70 equals 15 over x. Put the ratio over 1 and cross multiply. And I get 15 equals x cosine 70. Now, the x is on the side of the cosine 70. So what we want to do is divide by cosine 70. And so in Desmos, we're going to put 15 over cosine 70. 70. 43.8. I'm going to round it up to 6. 43.86. All right. And that's how you do that. Okay, so you can try 3C and you can post in the organizer. Ooh, and look at that. It looks like it might be, and it is a 30, 60, 90 triangle hiding in the trig section. Okay, and this is so long. All right. So that's going to be the first part, and then we will do the second part. We'll do 2, example 4, 5 as review the first week after break. Okay, and if you want to do that now, you're more than welcome. But we'll stop at what we did so far. So the IXL, let's look at IXL. What are we going to do this week? Hopefully you guys are enjoying the IXL practice assignment. Sometimes you want to use Khan Academy. Okay, so Q was the right triangles. Okay, so we're going to do R1. Well, why don't you try to figure out, we're going to skip 2. We'll do that next time. And R3. R5. So 1, 3, 5. And 6. Oh, 8. 1, 3, 5. 6, 8. 1, 3, 5, 6, 8. Yeah, 5. You could do it, and some of them are super fast and super fun. 1, 3, 5, 6, 8. All right. Write it down, and let's get it.